All right, moving on to demo number 2, which is going to be sodium chloride, which is known as table salt. It's your common table salt in water. So go ahead and answer questions number 1 and 2, which are the observations. Remember, for observations, you're thinking at the very least, you need to give us a state of matter and a color. And then for the water, you should be able to go on and say, is it a clear liquid? Is it a cloudy liquid? Is it an opaque liquid? For the salt, the sodium chloride, you should be able to go on and describe the shape a little bit. If you need to, just go ahead and enlarge the image. All right, so working on the mass. So here is an image of the water, and I included the beaker in the mass, just so you know, but the beaker will be present the entire demo, so there's nothing wrong with having that in the mass. And then here you'll watch me take the mass of the salt. So I've got the weigh boat on the scale, the little tiny weigh boat, it's so cute. And then we add some salt to it. From that, you should be able to answer question number 3. So go ahead, pause the video, and then record that, or calculate that, I should say. 4 and 5. So 4, we are taking the temperature on this one. And so you can see the temperature on the LabQuest. What you see in here is a temperature probe. And then we want you to do number 5, which is classifying sodium chloride. Do you think sodium chloride, based on the name, is it an element, a compound, a homogeneous mixture, or a heterogeneous mixture? All right, next one. Once you know that, we want you to draw a MOM diagram of the sodium chloride. Again, the things you're thinking about always are start with the state of matter. That will tell you how the particles are arranged. And then second of all is an element, compound, homogeneous mixture, heterogeneous mixture. Go ahead, draw that, and then, so pause the video, draw, and then start the video up again when you want to see how I do it. All right, so what I'm thinking when I'm doing this, so I know that the salt was a solid. So my particles are going to be touching and organized. The last time I did one, it was just iodine. One word, one thing found in the periodic table. This, when I look at the name of this, there's 2 parts. First name, last name. Both sodium and chloride are found on the periodic table. This is a compound. And if you remember from Miss Ehlert's video, the way we draw a compound is we want to show the 2 things, but we also want to show that they're bonded together. So I'm going to draw a line between the 2 of them to represent the fact that they're bonded. So I have my square bonded to my triangle right next to, and actually I would not think that's good enough. There you go. I want it right next to it so they are all touching. And I know it's a little bit hard on my screen, but as you're doing it on your paper, you should actually be able to get these things to touch. And you don't need to fill them up entirely. We just need to see enough, at least draw 4, 5, maybe 6 of them so that we can see how they do compare to each other. All right, next one, number 7 is how you draw water. Okay, so with water, we use kind of a different set of rules for water because it's incredibly unique and we use it so much. So in this case, if water is used to dissolve something, all right, this is how we're going to draw it. I actually just want you to use X's to draw water. And you just have a whole bunch of them. What we usually would do, if you follow our rules exactly, it would be a liquid and it would be a compound. So according to those rules, water really should look like this. However, because we use water so much to dissolve things in our class, and whenever we're doing this, it's called a solution. Using X's is just going to be a much easier way to do it. So you can just use X's as your water if we're going to use water to dissolve something. All right, so let's see what happens. So with this one, you're going to be answering 8, 9, and 10. So you're going to be watching what we see. You're going to watch the temperature change. You can already see the mass here, and then the after. But let's see what happens with the temperature and what we actually do. So I take the salt, pour it in, trying to get as much of it as possible so I do not have any lab errors. Use a stir rod because that is the proper tool to use when stirring things because it will not react. And then realizing that you can't really see the temperature, so we're going to make that a little bit better. There we go. There's the temperature. I bet we can make it even better. Oh yeah, let's do that. Good idea, Miss Hom. All right, so with this you can record the ending mass, the ending temperature, and then take observations, and then start the video up again when you're ready to go. All right, model of matter. So now we want you to think about what just happened, the table salt, where did it go, and how would you represent that one? So this one, again, we want you to be a little bit creative. It's okay if you're wrong, but you want to start with, okay, what's in there? How does it compare to the stuff I started with, and what's different about it? So give yourself a little bit of time to think, process it, and draw your best effort. Again, you're going to want to be drawing a particle model. You're not just going to draw this big picture of, I don't want you to just be like, oh, look, water dissolved like that. I don't know what's going on with the particles. You're really trying to go into the microscopic, what's actually going on with the particles. So go for it and start the video up again when you have something drawn. All right, so here's how we dissolve. So usually we're able to have a conversation about what happens when something dissolves, because sometimes students think that it just goes away. But if you look at the mass, look at your starting mass up there in number 3 and your ending mass in number 9. It's the same mass. The salt is still there. All the water is still there, and nothing else really happened. I did not have a color change. The temperature stayed the same, which would be another indicator of a chemical reaction going on. So that stays the same. So I have to show that I have a liquid in the end. And the liquid contains both water and my sodium chloride. But I can't see the sodium chloride anymore. So when I drew my sodium chlorides next to each other, I could clearly see it because that's all I had. But now it goes away, and we have to think about what happens. So what actually happens, I'm just going to draw one on the outside here. And I believe... Sorry, I have to run back and check. I believe I went with a square and a triangle. I need to make sure I'm consistent. But let's just assume I did, because I erased it. So I have my square and my triangle. And now what the water actually does is the water completely surrounds it. So it's able to separate the salt's particles from each other and surround them. So that would just be one thing dissolved. So I'm going to draw a few of them in here for my actual ones. So go ahead, you can copy this. So whenever I draw this, and what I'm drawing here is a solution. A solution is a mixture of two things that are very evenly mixed up together. So every sample I take would have the same combinations. And it's also known as aqueous or aqueous, depending on how you pronounce it. So I have my compound, and then I'm going to show my water. So water is completely surrounding it. So it's still, the water is still touching because I don't look at it and have these big gaps of air. So I know everything's touching. And it looks like water, which leads me to believe that I have a lot more water than I have of the salt. So mostly what I see is the water, but the salt's in there. If I drink that, and you should never drink things in the lab, but if I drank that, it would taste salty. So that is how you draw something dissolved. So again, I still have the sodium chloride and I have the water, but now it's all mixed up and the salt is evenly spread out throughout the water. It's a saltwater solution, also known as an aqueous solution. All right, so now we're going to let you guys try this last question, question number 12. So again, you're going to use the same template, kind of the same sentence structure that we used in the first demo. So you're going to say what the teacher did, and was that a chemical or physical change? And then the word because is a really good transition word, or the word because works best. What evidence do you have to support that? What do we know? What have you seen that fits that definition of whether a new substance was created or not? Go for it. And then we'll move on to demo number 3.